Hello everybody, welcome to my channel Practical Power Electronics. Let's study a shunt resistor. I have here an example 150 amps and 60 millivolts 0.5% shunt resistor. Let's study what is the real resistance of the shunt. Nominal resistance value is 60 millivolts divided by 150 amps, which is equal to 400 microohms, plus minus 0.5%. So the minimum resistance is 400 microohms times 1 minus 0.5 divided by 100, which is 398 microohms. And the maximum value is 402 microohms. So the resistance should be in between 389 microohms and 402 microohms. The next step is making test setup. I am using laboratory power source, two 1 ohm 100 watt resistors in parallel, precision ammeter and precision millivolt meter, and I'm going to use about 10 amps current, and I'm going to measure it in both directions. Current goes this direction and later on it goes opposite direction. This is a real-life test setup. Here we can see power source, two resistors in parallel, precision ammeter and precision millivolt meter, and the shunt resistor. Here we can see the results of positive current. We have 9.980 amps and 3.995 millivolts. Let's write those numbers down. And this is the opposite direction. Now we have minus 9.980 amps and minus 4.001 or 000 millivolts. Let's write those numbers down too. Here we can see the test results. For positive current we have 3.995 millivolts, and negative current we have 4.001 millivolt. There is a 6 microvolt difference between the results. And where does it come from? We can imagine that we have ideal resistor in series with small voltage source. This is called Seebeck voltage. And we actually measure our millivolt. This resistor voltage drop plus or minus this Seebeck voltage. We can write down pair of equations, this one, and make assumptions that those current are equal but opposite direction. So then I1 is equal to minus I2. Based on that, we can derive this end equation. And when we substitute the actual values into the equation, we obtain a result of minus 3 microvolt. Then we can calculate the actual value of the resistance, which is 406 microohms, which is well within the tolerance range 398 to 402 microohms. Also, we can calculate the error, which is plus 0.15%. Thank you for watching. See you next time.